All right. My name is Dr. Ben Davis. A lot of you probably already know me since I'm a former GOH of LibertyCon. And today's talk is on 50 years of SETI. Where is everybody? So back before I became semi-retired and became a professor again, I used to work in industry and used to sit in my office and ponder lots of different things. And the thing that I love to think about the most was the search for extraterrestrial intelligence and why we haven't heard from the aliens. And of course, the crux of this starts with the Fermi paradox. For those of you who don't know, Enrico Fermi was a brilliant nuclear physicist that lived back in the days of the Manhattan Project. He actually made the first reactor pile at the University of Chicago. So he goes way back to, say, the mid-30s. But he was well known for being able to cut through the crap and just basically get to the bottom of a lot of complicated issues. One of the stories they tell on Fermi was back when they first started testing the first atomic bombs. He was standing out in a field, the bomb went off, the shock wave came through, and he dropped a couple of pieces of paper, and he watched the paper float to the ground as the shock wave came through. And he said, okay, the yield on that was going to be about 15 kilotons. And everybody just looked at him and said, Enrico, you must be crazy. You can't figure out the yield on that bomb standing a mile away, watching the wind blow. So they went off and they ran their old-timey computers for a couple of weeks to finally, and with all their sensor data, and lo and behold, sure enough, the yield of the bomb was 14.9 kilotons. So he just had a way of sort of cutting to the chase. And so now we fast forward to 1950, literally the year 1950, and he's in the lunchroom with some of his fellow scientists, and they were talking about alien civilizations and extraterrestrial intelligence. And Fermi basically made the comment, well, they're not there. And they said, what are you talking about? And he said, well, if they were there, they would already be here. And so his logic went something like this. The universe is very old. And if there was an alien civilization that was technically advanced, had intelligence, and they even got, say, 100-year head start on us, which would be the blink of an eye in terms of the age of the universe, then Captain Kirk would already be parked over us with his starship, beaming down to talk to us. So the fact that nobody has shown up is an argument for the fact that nobody's there. Certainly nobody's ahead of us technologically. Now, that's a hard pill to swallow. So we start with this slide, some basics to remember. The universe is said to be 13.8 billion years old. The Milky Way galaxy, which still contains first-generation stars, is thought to have formed 10 to 12 billion years ago. Let's say 10 billion for the sake of argument. And let's say that the Milky Way, I don't even try to do the math on the entire universe. Let's just keep it within this galaxy for the sake of this talk, right? So anyway, we have first generation stars in the Milky Way. So our galaxy is reasonably old from that point of view. 10 billion years is a good estimate. And our Earth is about 4.5 billion years old. Life began on Earth and developed into a technological society about 3.5, 3.6 billion years ago. That's when life began, not when we developed into a technological society, of course. That was just a couple hundred years ago. So this is from another talk, my singularity talk. And this basically shows an exponential curve, sort of in reverse the way it's done. This is one of Ray Kurzweil's slides from back when he was all excited about singularity and all that. But what you see here is you see that life began. You see that a whole lot of time passes before you get multicellular organisms. And then you see a whole lot more time pass before you get to reptiles and mammals and primates. But then all of a sudden, all of these things that we think of as marks of intelligence just take off exponentially. So in practically no time at all, you go from the primates coming out of the trees to the personal computer and the internet. So this is on the order of, well, 100,000 years, right? So this goes back to Fermi's argument that if somebody got even a head start on us of 1,000 years, then they'd already be here. Assuming that they follow the same track of development, think the same way we do. And these are all things that we're going to discuss as we move forward in the talk, because these are all hopefully, reasons why we haven't really visited with ET yet, or he hasn't visited with us. So key point, not to be missed. We have a 10 billion year old galaxy, and it takes about 5 billion years to make a technically based planet. So the galaxy has the potential to have been growing advanced societies for the last 5 or 6 billion years because it's 10 billion years old itself. And there are upwards of 100 billion star systems in our galaxy. Now, thanks to the Hubble Space Telescope and some new sky surveys, that number is more like 200 billion, and some people say even 400 billion star systems within our own galaxy. Again, we're not even going to try to talk about the universe at large, right? So where is everybody, and why aren't they already here? The size and age of the universe incline us to believe that many technologically advanced civilizations must exist. However, this belief seems logically inconsistent with our lack of observational evidence to support it. Either the initial assumption is incorrect, and technologically advanced intelligent life is much rarer than we believe, or our current observations are incomplete and we simply have not detected them. Or perhaps our search methodologies are flawed and we're not searching for the right indicators. So this breaks down into 5 questions as far as I'm concerned. Is anyone out there? If they are out there, how's our hearing? Are we actually looking for the right things? Why aren't they already here? And possibly, are they hiding from us deliberately? And that would certainly explain a lot of things. If you have a technologically advanced society and they are deliberately being stealthy, then we would never hear from them. So, is anyone out there? The rarity question. All right. This presumes the principle of mediocrity. The principle serves us well in physical observations, but could be a fallacy when searching for intelligence. Put another way, assume you're the only smart person in the world. You might want to believe, even assume, others like you exist, but that doesn't mean they actually do. So the principle of mediocrity is great when you assume that the laws of physics are the same for a star 1,000 light years away, but it might not really apply in terms of evolutionary life and whether intelligent life can crop up in the same way that it did on Earth. So we could be flawed, or Fermi, if we go all the way back to Fermi, Fermi could have been flawed in his reasoning to think that the evolutionary tracks would be anything close to like what it is here everywhere in the universe. We could have, in other words, we could have just gotten lucky. So this is like one of my favorite 3-dimensional slides ever. So the question then becomes, how's our hearing? So what you've got here is, this is from an old Sky and Telescope article about SETI, obviously. And these are all the various SETI projects. And so in terms of depth of this graph is the frequency spectrum on which these surveys are being made. The height of the graph tells you the relative depth into space. And I've got a graphic coming up on that here in just a second. And the bottom of the graph, if you will, is a fraction of the sky covered, with 100% being the very bottom here. And you see a lot of these sky surveys only cover a tiny fraction of the sky. So all of our radio telescopes out there trying to hear ET talk to us, or at least pick up on their noise from other communications, are sort of plotted out on this graph. And you see that there's a pretty narrow frequency range in which we're listening. You see that for most of these projects, there's a pretty small fraction of the sky. And most importantly, most of them do not penetrate very far into space. Everything gets lost in the signal to noise ratio after, say, 10,000 light years or so. Remember that our galaxy is 100,000 light years across. So it's not a big window that we're looking through. Now, I told you all that, as Ron White would say, I told you that story to tell you this story. The two biggest pictures on that graph, the omnidirectional search system and the Allen telescope array, pretty much don't exist. So this was looking into the future, with new initiatives coming online. The omnidirectional search system never got funded, never got built. The Allen telescope array started to get built. They got, if I remember right, they got about 10, 20% of the way done, and they got defunded, didn't have the money to do it anymore. And they sell out at least half of their time now to the military looking for spy satellites. So they don't even get to use the equipment that they put together for the actual SETI program half the time, as they try to cobble together enough money to build more telescopes, radio telescopes for their telescope array, and computer, equipment to search through the data and all of that. So in short, how's our hearing? Our hearing sucks. So that already tells you that it's not surprising that we haven't heard from anybody. It's maybe not because they're not talking, it's because we're not that good at listening yet. So put another way, this is a picture of course, an artist rendition of our galaxy. And centered on Earth, the red show, this is from my astronomy class I taught last term actually, but I like the graphics, so I dropped it in here. Centered on Earth, the red circle shows the region in which the astronomers are searching for extraterrestrial intelligence. So this gives you an idea of how big of a chunk of the galaxy we would be sensitive enough to hear something with. And everything outside of that circle is too far away for us. The other thing that you ought to take note of is the Earth is in what's called the Orion Spur. It's one of the smaller arms, if you will, of the Milky Way galaxy. And so the area in which we are sensitive enough to hear is not even very densely populated in terms of stars. So yeah, this is a problem. This is not nearly as trivial as you might think at first blush. Then there's the next question. Are we actually looking for the right things? And again, this is not a trivial question. Back in the 70s, when they first started talking about, late 60s, early 70s, when they first started talking about the search for extraterrestrial intelligence, radio telescopes made a lot of sense. They make a lot of sense because if you ever look at a graph of transparency of the Earth's atmosphere to electromagnetic radiation, you see that the atmosphere of the Earth is transparent for radio waves and for visible light. Certainly explains why we evolved eyes that are sensitive to visible light and not other forms of electromagnetic radiation. That's what actually makes it to the surface of the Earth and the sun, not without being absorbed in significant quantity by the atmosphere. Of course, the other thing is radio waves. So we use radio waves for communications ourselves because the atmosphere allows us to. And we like to use radio telescopes to look at the sky because viewing conditions are wonderful in that part of the spectrum. But is that going to be true for every alien civilization? And I think the answer to that question is obviously no, right? Different atmosphere, different opacities of radiation. So here's the other issue. Remember that communication within our civilization has been based until recently on broadcast radio communication. Again, this goes to why it made so much sense in the 70s to look for aliens using radio waves. But telephones don't emit radio signals, and neither does the internet. We ourselves may only transmit any real volume of electromagnetic radiation into space for, say, 60 years or so. And then we're going to all move to streaming video. Most of us already have. We're already going to move to streaming video over the internet, and radio is becoming less and less prominent even in our own society. So there's probably only going to be, realistically speaking, 100-year window of us transmitting all that energy out into space for no good use. Another thing that I don't think can be completely discounted is our civilization is also based on electrical distribution and fossil fuels. So everything's driven by electricity in our society, in our world. But what if that isn't the technological base for all civilizations? What if you had a civilization that came up that didn't have fossil fuels they could dig up out of the ground and didn't have all this easily accessible sources of energy to use radio communication or all the other things we take for granted? Again, it's not a stretch to think that another intelligent society might not have that kind of thing available to them. So they're not going to be making all this noise, all this radio noise that can be heard out in space, because they don't have that kind of energy to waste on their planet. Going back to Fermi's original argument, why aren't they already here? So the question presumes that colonization or exploration is needed or desirable by the society in question. We're predators, we're apex predators, and presumably an intelligent civilization would be apex predators, but maybe not. Maybe they're not as violently turned as we are. Maybe, if you've ever, I remember when I was a kid, my dad used to take me deer hunting. You'd be out there in the woods, and if that deer even heard a twig snap, that head would go up, and you'd have about a half a second to make the shot before that deer was gone. So if you have some sort of society with some sort of species that isn't carnivorous, isn't really what you consider to be a predator, they might be naturally afraid, maybe isn't the right word, but naturally less inclined to want to talk to anybody they didn't know. And we actually see some of that within our own society. Stephen Hawking is one of those guys that has jumped up and said, you know what? We don't really need to be talking to aliens because some of them may not be very nice. Now, I don't actually agree with Hawking on that. And, Neil deGrasse Tyson, for example, and I share a similar philosophy, which is any advanced society is probably going to be peaceful and we don't have to worry about them hearing us. We're not going to have anything that's important enough to them that they're going to come and attack us for our resources, fly halfway across the galaxy to do it. That's sort of ridiculous, may be a strong word, but that's sort of far-fetched in my mind that scenario would ever happen. But we have intelligent people in our own society that are already warning us about reaching out and talking to aliens. So in some other intelligent society, it's entirely likely that conversation is being had as well. The other thing that I think isn't talked about enough and isn't recognized enough is that it may be that the speed of light really is the universal speed limit. There's no wormholes or warp drive to talk about here. And so, it just simply isn't feasible to cross that 100,000 light year gulf or even 1,000 light year gulf to come talk to some other civilization, even if you've detected it, even if you know it's there. That would severely limit our drop-in visits from any neighbors, even if we had neighbors just 4 light years away. But that still doesn't, of course, explain why they haven't called as far as reaching out to us through, laser signals, electromagnetic radiation, radio, that kind of thing. And again, something that can't be overlooked. Are they hiding from us? Fear is often a big motivator in any society, but this might be especially true for a society made up of non-predators, as we talked about earlier. Contact with a new race that has easily demonstrated a capacity for violence, I'm talking about us now, would be a daunting prospect. Based on their own society, the aliens may have simply decided that even an exchange of ideas with us would not be in their best interest. At best, they may feel like there would be nothing to be gained by it. In other words, we're just not that interesting. And then there's this. Oh, sorry, stuck another slide in there in front of it. The Dyson sphere. This is an interesting concept. The concept of the Dyson sphere was the result of a thought experiment by physicist and mathematician Freeman Dyson. When he theorized that all technological civilizations constantly increase their demand for energy. He reasoned that if our civilization expanded energy demands long enough, there would come a time when it demanded the total energy output of the sun. He proposed a system of orbiting structures, which he referred to initially as a shell, designed to intercept and collect all the energy produced by the sun. So this is a giant solar battery around the entire sun of some advanced civilization. It's funny, I was watching a YouTube video and I didn't have a citation on it, so I didn't make a slide for it. But I was watching a YouTube video just the other night getting ready for a talk. And there are people that are going back and looking at old slides from astronomical observations. And they have actually found at least one case, I've seen the picture of it, of a faint star that has gotten fainter over time and has actually disappeared. So this concept of the Dyson sphere, where they're covering up their sun and they're going completely in the dark to us, may not be so far-fetched. And that might be how we figure out there are aliens out there, advanced aliens out there, by going back through the old data and finding stars that have gone dark on us. Because usually they don't go out that way, right? Usually they go nova or they go through some sort of red giant phase or something. They don't just sort of fade out and disappear. There's no model in our physics to explain a star that would do that. And yes, in the historical data, there does seem to be indications of that happening. All right, so back up to that slide that I missed. What might alien contact do to our society? So this now becomes sort of a different discussion. And it sort of goes to the conspiracy theorist. What if the government knows and they're just not telling us? Fortunately, that's a credible concern, right? They were not good to Nicholas Copernicus when he, suggested that the sun was at the center of the universe. They were not good to Johannes Kepler, who was excommunicated by the Catholic Church, which was a really big deal for him, or would have been had he not published after he died. So we don't have a good track record for being told we're not God's favorite. An alien version of the Prime Directive would be justifiable in that, because it might actually make people go plumb crazy in our society. So it could be that the government's hiding this from us, or it could be that the aliens have decided not to talk to us in their own accord as a way of protecting us. And again, hate to think that's what's going on, but it is a possibility. So it's certainly something that has to be considered. So the recap, should we despair? What if they don't want to talk to us? Either by prime directive or just fear of the effect we'd have on them. What if they can't talk to us deliberately? Dyson sphere, for example, or no electromagnetic transmissions from their planet. Or inadvertently. You know, there's a whole lot of things that keep us from moving forward, you know, as our own planet and world. There's, of course, the old Comus Malthus, famine, pestilence, and war, you know, idea that's keeping us from you know, being able to look outward and devote a lot of resources to that. And we have nuclear treaties that don't allow us to use nuclear power in space, or certainly severely limits us from doing that. So we can't really be very efficient at sending signals out there for other societies to see either, just because of some of the limits imposed by our own societies and the fact that we don't have a unified world, right? And there are other countries that we don't trust. But we can't put up a project like that because we don't, you know, they don't trust us, and they can't put up a project like that because we don't trust them. So there's no concerted effort here to actually talk to the aliens, and it's entirely possible that there's no concerted effort on their planet either to talk to us. So in the final analysis, I think there are two major problems that can pretty much explain everything. Our hearing is not nearly as good as we'd like to believe. Couple that with faster light travel not being a real possibility. So physically coming over here is probably not something that's going to happen. So that already cuts us off. That already isolates us. And the fact that we haven't heard from anybody really shouldn't be that surprising. And of course, the number two issue is we're simply not that interesting, not yet anyway. And contact with us would be anywhere from pointless to harmful from an extraterrestrial point of view. All right, so that was my original talk when I first gave this talk, I don't know, 8 years ago. And every time I give this talk, I end up going through the slides faster, so I always add a little something to the end. And so here is the Drake equation. I've simply put it in because you can't have a talk about the search for extraterrestrial intelligence without at least mentioning the Drake equation. The thing that's most interesting about it is its estimate on the number of civilizations in our galaxy with the ability to communicate at this current point in time, or really at any point in time over the lifetime of the galaxy. So it starts with the number of stars, and it multiplies that by the fraction of stars that have planets around them, multiplies that by the fraction of planets that support life, and on and on and on. It becomes this endless list. This is a very simplified version of it. It becomes this endless list of 20 or 30 terms, depending on who you're asking and talking to, of total number of stars multiplied by all these fractional numbers to give you an estimate on how many actual intelligent civilizations are out there in the universe right now. The thing about starting with a big number and then multiplying it by 20 fractions is there's a lot of error bars in that type of calculation, right? So estimates can range from 1, us being the only civilization alive at this moment in the history of the galaxy, to 36.4 million. So it's not, and I left it out of the original talk because it's not really that helpful. When you have a formula that gives you an answer anywhere from 1 to 36.4 million, that's not a very helpful formula. I did take my shot at it just for the sake of fun. So this is my value add again, after initially doing the talk 8 years ago and adding extra pieces to it. Some of these fractions are a little more accurate than they were in Drake's time. You have the Kepler telescope, finding all of these exoplanets. And so the fraction of star systems that actually have planets around them have gone up dramatically. The Hubble Space Telescope telling us there's a lot more stars in our galaxy than we originally thought. So that number's gone up quite a bit. But anyway, when I ran the numbers myself, my best estimate, my shot at the Drake equation and trying to figure it out for myself, came up with something on the order of 1,000 civilizations in our own galaxy at this point in time, given a certain lifetime. I assumed 1,000-year lifetime of every civilization. Everything comes to an end, guys. People die, civilizations die. So you don't presume with this formula that even an advanced civilization lives forever. If they did, then Fermi would be, right in his concerns. Now, the 1,000 civilization number, I took a step further. So again, here's my value add. I said, what if there is actually 1,000 civilizations out there right now in our galaxy? Again, I don't even try to deal with numbers for the universe at large. Just our galaxy's mind-boggling enough. So I got to thinking about that. And I basically came up with an average distance. I refer to it as my sphere of isolation. Average distance between civilizations, given the geometry of the galaxy, if there is 1,000 civilizations out there right now. And our 6 nearest neighbors would be, on average, 1,000 light years away from us. So we'd be 1,000 light years apart. If they transmit for 100 years out of their 1,000-year existence as an advanced society, that gives you a 10% chance of detection for any one of those 6 civilizations that are closest to you. If you run those numbers, you find out that there is a 47% chance of us even hearing anybody, just based on the window of time that you'd be listening versus the window of time that they'd be transmitting. And the fact that here we are, there's 6 of them within 1,000 light years of us, and we still only would have a 47% chance of detecting anybody. So this goes to the whole, how's our hearing? Our hearing sucks. That's how that goes. But that was a fun calculation to do. And it tells you just how, how rough it's going to be to find ET out there. So again, I gave this talk at DragonCon back in 2016. And the big thing right there was Katie's star, the alien megastructure. So that got real exciting for a while. I certainly had to make a slide for it because I knew that I'd get questions on it. And I was in the camp, man. I'm hoping, hey, this is a Dyson sphere being built. They actually refer to this as a Dyson swarm. But what you had is you had a star that somebody had found that had been dimming and brightening back up in unpredictable ways, things that didn't look natural, things that looked like maybe somebody was building all these satellites to collect all of this energy from the star and blocking out the light in ways that we'd never seen before. Further analysis, well, what can you say? They've now decided that it's just it's a broken up moon, is what they're saying. And I guess the thing that made it unique was that not everything was in the solar plane So what they eventually figured out is this cloud of dust around the star that was causing this intermittent dimming of the star was just a moon from some planet that had broken up and had spewed all this garbage in all directions around the sun. So, alas, they don't really think that they don't think Hades star is the signature for an alien megastructure or a Dyson sphere in the process of being built. But again, as I pointed out earlier, there are people that are going through the historical record now and looking for stars that we got pictures of 100 years ago and making sure that all those stars are still there. And they've already found some candidates where they're not. So this may yet be the kind of way that we find a signature of an alien civilization in the future. So there are initiatives being made. Hopefully our hearing will get better in the near future. One of the things that I heard about back in 2017 that got me excited was the Breakthrough Listen program. So there's a billionaire out there that's funding a new SETI program. So hopefully we'll get more data and hopefully things will get better. And we'll have, a better chance of hearing ET if he is out there talking to us. So, new slide for this talk, the final analysis. So this is just to sum up everything. Is anyone out there probably to say no is just unpalatable to us? Maybe not unlogical, but certainly it's just hard to accept. So we can probably presume somebody's out there. How's our hearing? Not very good. Our electromagnetic window and time windows are still quite small. Are we actually looking for the right things? Relying on detecting abundant electromagnetic radiation is a real problem, even as we are drastically cutting back. So, no, you might find out that radio communications is not going to be the way we find ET. Why aren't they already here? Colonization, exploration just may not be economically or energetically feasible. And the speed of light may really truly be the galactic and intergalactic speed limit. Are they hiding from us? Well, they certainly have little reason to try to make themselves apparent, but likely wouldn't bother hiding would be my guess on that. The point 3 is why we likely have failed. But what's the alternative to electromagnetic radiation? Well, we have to wait hundreds of years and see if these stars are actually dimming because somebody's building a Dyson sphere around them. We have to be better at finding exoplanets and analyzing the light that passes through the atmospheres of those exoplanets and looking for telltale signatures in the atmospheres of industrialization. All these things are not straightforward and easy, and they're all going to take a lot of time, but that's probably the way we're going to actually find the signature of some other intelligent life somewhere. And so that's it. That's all I got for you on this talk. Thank you for listening, and have a good time at LibertyCon.